I'm Luca Congedo and you're watching From GIS to Remote Sensing. This tutorial is about the estimation of land surface temperature starting from a land cover classification and calculating surface emissivity. So in this tutorial we are going to use a Landsat image. We can download the Landsat images, so in the SCP menu select Download Images, download Landsat. In this interface enter the user and password of the service. In this case, however, we are going to use a Landsat image acquired in 2016, which is available from the Amazon service, which doesn't require a password. So here enter the search area, the upper left coordinates, 2 for longitude, 49 for latitude, and lower right corner, 2.5 longitude and 48.8 for latitude. Here we can set the satellite, so we are searching a Landsat A satellite, but we could also search for other Landsat satellites. And we can set the acquisition date. So here type 2015-9/27 because the Landsat image that we are going to use was acquired on the 27th of September 2015. Then click this button Find, and after a few seconds we have the image listed here in the image list. Select this image and click this button to display the image preview. Here we have the image preview. Sometimes the colors are not correctly displayed, so just click this button here in QGIS to display the image correctly with the proper stretching. And in the interface click Download Options. So in Download Options we are going to select the bands that we are downloading, so uncheck band 1, we leave these bands checked, we uncheck band 8, panchromatic band, band 9, we leave band 10, which is the thermal band, and we uncheck band 11 and band QA. We are also going to set these options here. In particular, we are going to use the preprocess images. When this checkbox preprocess images is checked, after the download of the Landsat band will be converted to reflectance using these settings. So we are going to check here, apply this one atmospheric correction, and we uncheck create bandset because we are going to create the bandset later. The Landsat band 10, which is the thermal infrared, will be converted to brightness temperature. So now in the Landsat download we can click this button Run and select an output where we are going to save our Landsat images. And when the download is finished, we have here loaded in QGIS the Landsat bands automatically corrected and converted to reflectance. So now we are going to clip the Landsat image to our study area, which is the area of Paris in France. So in the SCP menu select Clip Multiple Rasters. Click this button to refresh the layer list and select all the bands loaded in QGIS. So we are going to clip these Landsat images using the coordinates. Click this button and with a left click and the right click in the map we are going to set the clip area. As you can see here, the coordinates. However, we are going to set manually also the coordinates here. So for the upper left and lower right corners, enter these values as described in the tutorial. And now we can click Run and select the output. When the process has finished, we have all these clip bands loaded in QGIS. All these bands starting with the clip. We can select and remove all these Landsat images because we are going to use only these rasters that were clipped. Now we are going to create a land cover classification, so select the bands, the clipped bands that will be our input for the land cover classification. So we're going to set the band set here. We're going to use only the visible and infrared band, so remove the band 10. And set the center wavelength, selecting Landsat 8 in the quick wavelength settings. So this is the input of the land cover classification. Here we can see that band set is defined as input image. So if we now select an RGB 432 color composite, we can see here this color composite created on the fly. We can see here vegetation in red and the urban area in blue in the center of the image. So now we're going to create the training input. So click this button here and define the training input file. So here we are going to create several rows for creating a land cover classification using the SCP tools. So for instance, we can create here a row for the built-up area. In particular, we are going to use this for land cover classes: water, built-up, vegetation, and bare soil. So after the collection of several rows and of course the calculation of the respective spectral signatures, we can create a preview. In particular, we are going to use the maximum likelihood algorithm and select the macroclass ID for the classification. When we are satisfied of the result, we can click this button Run and select the output destination for the classification raster. And click Save. So after the calculation, we have here the land cover classification of the study area according to these 4 land cover classes. And now we are going to reclassify the land cover classes to the emissivity values. So in the SCP menu, select Post-Processing and Reclassification tool. In this tool, click this button to refresh the layer list and select the classification raster as input. Next, click this button to add 4 values, 4 reclassification values, and enter as old value the macroclass ID. So 1, 2, 3, and 4. In new value, we are going to set the emissivity values. So here, these are the old values according to the macroclass ID. Here, as you can see, these are the old values. And in the new values, we're going to enter the emissivity values according to the land cover class. So 0.98 for water, 0.94 for built up, 0.98 for vegetation, and 0.93 for bare soil. Next, uncheck Use code from signature list. and click this button Run to select the output of the emissivity raster. So set a name, for instance emissivity, and click Save. After a few seconds, the emissivity raster will be calculated. As you can see, this is the reclassification of our land cover classification. Now we are going to calculate the surface temperature using the emissivity raster. So click this button and open the BandCalc tool of the plugin. So we are going to use this expression here, where surface temperature is a function of the brightness temperature and the emissivity. So here in the BandCalc expression, click the name of the band 10 raster, which is the thermal infrared band of the Landsat 8 image, divided by, open parentheses, 1 plus, open another parenthesis, 10.8, which is the center wavelength of the band 10 of the Landsat band 10, times the Landsat band 10 divided by 14,388, close parenthesis, times a logarithm of the emissivity. And close the parenthesis. So when this expression is green, we can click Run and select the output destination of the surface temperature raster and click Save. After the calculation, we have here the surface temperature calculated in Kelvin. So we can also convert the surface temperature from Kelvin to Celsius. So in the BandCalc, click this button to refresh the layer list and select the surface temperature minus 273.15 and click Run. So we're going to calculate this new raster where temperatures is calculated in Celsius. So here we can define a symbology for our surface temperature raster. Classify here the intervals. And here we have the surface temperature. You can see here that lowest temperatures are over the vegetation areas, while highest temperatures are over built-up and urban areas. Okay, so we have calculated the surface temperature of the Landsat image. We can do the same using an ASTER image, which is now freely available. So open the ASTER download tool and enter here the username and password of the NASA account, which is required in this case. So click this button, then in the map left click and right click for defining the search area. Then in the search parameters enter the acquisition date from and to, enter 2008-24, because we are going to use an image acquired on the 24th of August of 2000. Then click this button Find Images, and after a few seconds we have here the image which was acquired in 2000. So we're going to download this image. Select this image and click this button to display the image preview. So here we can see the ASTER image. Now in the interface of the plugin, select Preprocessing ASTER, because we are going to set the parameters for the automatic conversion after the download. So in particular, check Apply DOS1 Atmospheric Correction. We can leave this time checked Create Band Set, because we are going to use these bands. Then in the Download ASTER tab, click Run and select the output destination. We can see that all these bands were automatically loaded in the band set. But now we are going to clip this band, because as you can see here, these bands have a little shift one from the other. So here you can see not all the bands are perfectly aligned, and we need to clip all the bands to the same surface. So we can use the tool Clip Multiple Raster here. So here in this tool, refresh the layer list and select the downloaded and converted ASTER bands. Here. And then we can use this option here, use temporary ROI for clipping. So in the toolbar, click this button to define a ROI and draw a ROI which is slightly smaller than the image area, so that all the pixels will be aligned. Then, in the Clip Multiple Rasters tool, click Run and select the output destination. After the process, we have here all the clipped bands, as you can see here, loaded in QGIS, and all these bands are now aligned and ready for the classification. So now we're going to use these clipped bands as input for the land cover classification of the ASTER image. So we now clear this old band set and select the ASTER bands that we have clipped. So here we check every ASTER band, but we're not going to use the thermal infrared bands. So select these bands from 1 to 9 and set the center wavelength of the bands. So here we can see the color composite of the ASTER image. We can see here that the color composite 321 represents the false color composite with the near infrared, which is the band 3. Next we create the training input file. So for instance, training ASTER. And click Save. So now, as we did for the Landsat image, we're going to create several ROIs. So now we should delete the old spectral signatures of the Landsat image. And we are going to create several ROIs for the same macro classes here. So for instance, one ROI for water, using the region growing tool. Here we can set the macroclass and the class ID. As you can see, the macroclass information is automatically loaded. And after the creation of several rows, here, of course, the same macroclasses, we are going to create a land cover classification using the macroclass ID and the maximum likelihood algorithm. We can see here a preview of the classification. So when the preview is fine, we can create the classification raster. In this case, enter the output name. So, as we did for Landsat, we have now the land cover classification. We are now going to reclassify the land cover classes to the emissivity values. We have here the same land cover classes and the same emissivity values that we use for Landsat. As you can see here, these are the values for the macro classes. And now we can click Run and select the output raster. So for instance, Emissivity ASTER. And click Save. After calculation, we have here the emissivity raster. So now we have the emissivity raster, and we are going to calculate the surface temperature. So click this button to refresh the layer list, and now we are going to enter the expression for the conversion of the brightness temperature to the surface temperature. So we are going to use the band 13, so double click this layer, divided by open parentheses 1 plus open parentheses 10.6, which is the center wavelength, times the band 13, which is the thermal infrared band converted to brightness temperature, divided by 14,388, close parentheses, times the logarithm of the emissivity, and close parentheses. So now that the expression is green, we can click Run and select the output destination, which is the surface temperature ASTER, and click Save. So now we have the surface temperature. We can, as we did for the Landsat, we can convert the temperature from Kelvin to Celsius. So click this button in the band calc to refresh the band list and type surface temperature minus 273.15 and select the output destination. So now we have calculated the surface temperature in Celsius. We can define a symbology. We can set, for instance, the symbology here with 11 classes. So we can see here the values, the temperature values of this ASTER image. Again, we can see that the highest temperatures are over built-up and urban areas. We can see here that lowest temperatures are over vegetation and water bodies. Of course, the accuracy of the estimation relies on the values of emissivity that we have defined here. So for better results we would need field measurements of the emissivity values for the different land cover classes. We can, for instance, compare the surface temperature of the Landsat image with the surface temperature of the ASTER image. You can see here the differences in the range of temperatures. The differences are caused by the different years of acquisition, but also the different seasons and land cover change. So well done, we have calculated the surface temperature. So in the next few weeks I'm going to upload other new tutorials, and please join the Facebook group and the Google Plus community. Thank you for watching.